All right, welcome back. Here's our proofs video. This is for 5, 6, and 5, 7. So what we're looking for is, what's my given information? So first step, what's given? Then you got to ask yourself, what do I still need? And we can use any vocab words in those given lines. Those will usually help us out quite a bit. And then we'll put down our prove statement, our statement of congruence. So first thing I do is I look at the figure. I've got GH bisects EGF. Okay, I'll keep that in the back of my mind for later. I have GEH is congruent to GFH. That's given. If I'm going to try to prove this by angle, side, what do I have? I have an angle. I need an angle and a side. So the next thing we should do is see if I have any reflexive property shared sides or if I have any vertical angles. I've got some reflexive property shared sides in the middle. So GH is congruent to GH. It's my reflexive property. We should always have that reflexive property in the back of our heads as well as vertical angles. So what was that? That was a side. So I needed a side and an angle. Got my side. Now I need an angle. And I don't see any vertical angles in here, but what I can do is I can look back at the vocab words in my given statement. And I'm given that GH in the middle here, GH bisects GEH. And I'll do that one in blue. Sorry, EGF. So that orange line bisects this big highlighted angle. And what does it mean to bisect something? Well, it means to cut it in half or into two equal pieces. So this EGH must be congruent to, it's congruent to FGH. Why? Because of the definition of bisector. What it means to bisect is to cut something into two equal pieces. Definition of bisector tells me that this angle up top was bisected or cut in half. So I've got a congruent angle side on the left and a congruent angle side on the right. So I've taken care of everything I needed, which means that now I can claim that GEH is congruent to GFH. And why is that? I have angle side. All right, so again, what were those steps? We used our given statements. Then I asked myself, what do I still need to prove congruence? I used my vocab word of bisector in the given line. And that was pretty much all I needed. So let's try the same thing down here. BC bisects angle ACD, and I have BA, what's going on? There we go. BAC is congruent to BDC. So I've got those angles marked in as congruent. I have BC bisects ACD, and I'm trying to prove this by angle side again. So let's see, what do I have? I have an angle down here. I have those two angles. Now I need an angle and I need a side. Well, let's see, do I have any vertical angles here? No. And do I have any sides that I could very quickly claim as congruent? Well, yeah, I've got the reflexive property side in the middle. You should always be on the lookout for that one. So I can say BC is congruent to BC by the reflexive property. So I have my side. Now I need an angle. Again, what should I do here? Looks like I've used up everything. I have no vertical angles. I'm going to look back at my given line and I'll see if I have any vocab words in here. And there's one. BC bisects ACD. So here's angle ACD. It's a 180 degree straight line, straight angle. And what does it mean for BC to bisect that angle? It means that it cut it in half or into two equal pieces. So what are each one of those two angles that it cut? So the two smaller pieces that add up to make the big ACD, well, that would be ACB and DCB. And those are congruent. Why? By the definition of bisector. Because what does it mean to bisect something? It means that BC in the middle cut my big straight line into two equal pieces. So by the definition of bisector, those two are congruent, and now I have my angle. So I've got everything I need. I have all three pieces. Then BAC is congruent to BDC by angle, side. And our last proof, why don't you guys try this one on your own, see how it goes, and then unpause the video and check your work. So here's my statements. Here's my reasons. So first thing I do is I copy down the given, TQS and RSQ. So down here, those are congruent. Angle R is congruent to angle T. That's up here. And that's all given. That's all given to us. So that's given information. And what are we trying to prove? We're trying to prove this is congruent by angle, side. And here's my triangle, TSQ. Let me draw these separately for us. And here's RSQ. So what am I given? I'm given an angle, done. Given an angle up top, cool. I need a side. So what side do they share? You know, where are they connected? Well, they share down here. That's where they connect. So QS and QS, they share QS. So I need a side. It looks like that's going to be the side I go with. I'll say QS, congruent to QS. That's my reflexive property. And that's my side. So now it looks like I have angle, side. So I have angle, side, which means that I'm done. And I can claim that TQS is congruent to RSQ by angle side. And that's what we're doing with these reflexive property sides. Notice that this is the same side, QS. It's shared. So if I put one on top of the other, they're the same length. That's why I can say those are congruent. And I say that it's the reflexive property because QS is congruent to QS. Something is congruent to itself. That is our definition of the reflexive property. So that's our proofs. Let me know what questions you have. Send me an email, join office hours, and I will see you guys in class.